So in this week's screencast, I want to go through a couple of different worksheets that I've worked through, worksheet 3 and worksheet 4. And starting off with worksheet 3, I had a decent time going through this. I think it made good sense, took a while to get through. I think the students would be able to work their way through it. I think that the main question for me, where we have an unclear question, was in the last problem here, number 4. It would be really nice if there was some kind of a diagram there. And what I had is, what I thought in my head was that you'd have a positive plate, say, on the left side, a vertical positive plate, and then on the right side you'd have a vertical negative plate. So there'd be an electric field stretching across. And the initial sentence, the proton's accelerating through a potential difference of 2.5 kilovolts. Okay, understandable. I do not understand here also that, okay, it enters a region. Between two parallel plates that has a potential difference of 250 volts. So I don't understand the two potential differences, exactly what that means. So I couldn't figure out exactly how maybe a diagram would look in order to solve this problem. I looked at the answer key, but again, I just, it was all calculations and there was no diagram shown. So that would be handy to have a diagram. I'm not asking you to do it, but I just think that I guess if I would ask this, I would want a diagram. And even better, some sort of a visualization, maybe on a computer, where you could actually, an animation where you could move particles across plates and see, corresponding effects. That's sort of the topic of our paper, is using visualizations for learning. And there's the TEAL project through MIT, which was recently created in the last 10 years. And that's used now to add a laboratory component to the MIT classes. But there's a series of good animations, and we hope to share some of those with you during next week's presentation. The next thing I wanted to go through was just some of the teacher notes and some of the issues that came up, I guess, and some points to make on that. So if we look here at our teacher notes, so there's terminology here that's a little bit new. There's electromagnetic induction, flux. I was also talking to my colleague about back EMFs, which seem to be formed as part of Lenz's law. But anyway, I didn't see really a discussion of that, and so that would be an interesting thing. And I'm just wondering if back EMFs are just caused by magnetic fields that are induced in wire that's moving through a certain magnetic field. But anyway, I didn't see any of that discussion. The labs, I pretty much did all the labs here in the unit. Another question I guess I had was referring to the discussion of motional ENF. So if we go here to page 20, so I do that. My computer's a little slow. I have a lot of tabs open. So the typers, just to mention it, are very interesting. I don't know if you've come across any answer keys to the typer um, books. I know there's a few you can find online, but it'd just be nice to check your work with the typers. But anyway, I'm not sure if that's something that you've come across, and if they even make the answer keys for them. Um, so worksheet 3, looking at these equations, that is, seems straightforward. The motor construction is very interesting because um, it seems that, so I had a student who tried to make a motor just like this, and they had a problem because they didn't get it to spin. It spun a couple times, but then it wasn't maintained. And so that's interesting because I was wondering why that happened. And it seems like I came across a discussion here. I'm not sure where it was, but anyway, a discussion. I thought it was in teacher's notes, but maybe not. The motor plans maybe I found. But anyway, you only take the varnish off one half of the wire on each of the posts that are sticking out, contacting the wires that are in touch with the terminals of the battery. And I guess I was wondering why that was. I didn't get a good understanding of that, but thought that was very interesting. So that's something to go back to and look more in depth at in the future. Also, this took me a while to wrap my head around, this discussion of motional ENF, which, I've taught this before, but at a fairly cursory level, definitely not sort of to the mechanistic level that modeling strives to attain. And so it was quite interesting. Thinking about the right hand rules, which way to point your thumb. What does your thumb represent? The motion of the bar in the magnetic field, or the motion of the charge in the wire, or in the bar that's induced by the magnetic field that it's in. And so, and that also had some relevance for me when I was thinking about worksheet 4 in terms of sort of whether or not, when predicting the direction of current, if that also represented the direction of the force on positive charge, which explains, for example, which side of the resistor has a higher potential. I guess, and so I'll discuss that when I get to it. And so I'm excited to use some of this right here because it's simple. It's not a lot of materials, but yet it demonstrates pretty complex ideas. Here, this took definitely a while for me to wrap my head around, and reading. So I read the teacher notes first, and then I needed more help in understanding. So I went, to my textbook that from my school, and then I went back to the matter and interactions text, which was very useful. Pretty complex, but it sort of got at the same, explanations of diagrams and such that were used in the teacher notes. And so, for example, here, this took me a while to realize why in the world the electric force would be equal to the magnetic force. So the magnetic force is produced in the bar, which causes asymmetric distribution of charge, which then causes an electric force. And so the reading really helped me, the matter and interactions. Now, that's not something my students would necessarily be able to grasp, and they probably wouldn't be able to spend so much time on it. So I guess it's just a matter of sort of the teacher being a little more in teacher mode when we talk about these kind of complex ideas. rather than having them sort of discover it.